Hello dear students of +1 medical and non-medical respected teachers. So today I am going to discuss variation of acceleration due to gravity with height, depth and due to shape of earth. So let us start. First of all, variation of G with height. So suppose this is our earth having radius r and mass capital M. Suppose a body of mass m lying at height h or distance small r from the center. So small r is equal to capital R plus h at height h. Let gh is equal to value of g at the height h and g is equal to value of g at the surface of earth. And we know that expression for acceleration due to gravity is given by gm upon distance square. So therefore gh is equal to capital Gm upon r plus h whole square, equation number 1. Similarly, g is equal to Gm upon r square at the surface, equation number 2, where g is the gravitational constant. If we divide 1 by 2, so we have gh upon Gm upon r plus h whole square into Gm, the denominator, over r square. So Gm cancels. So gh is equal to r square upon r plus h whole square into g, which is the required expression for acceleration due to gravity at height h from the surface of earth. Now, if you simplify it, if we take r square common on denominator, it will be r square into 1 plus h upon r square. So r square cancels, or we can write gh is equal to 1 plus h upon r or minus 2 into g. So since height h is less than r, when h is less than say few kilometer, radius of earth is 6400 kilometer. So this, by using binomial theorem, 1 plus x power n is equal to 1 plus nx simply. So we will have gh is equal to power minus 2 here, it will be 1 minus 2h upon r into g. So this is the approximate equation for acceleration due to gravity at height h. And it is clear from this equation, as h increases, g decreases. So at the surface of earth, value of g is maximum and it decreases as we move up. So we can see if h is equal to r by 2, that is if height is equal to half the radius of earth, gh becomes 0 practically. But theoretically, g will be 0 at infinity. So practically, when height, we go to the height having radius equal to radius, the half of the radius of earth, so g becomes negligible. So it means value of g, that is acceleration due to gravity, decreases with the increase of height and becomes 0 at h is equal to r by 2 practically, but theoretically it is 0 at infinity from the surface of earth. Then variation of g with depth. So what happens to the value of g when we go into the earth? Suppose this is our earth of mass m having radius r. Suppose we go inside through a depth d, so that this shaded portion of the earth has radius r minus d instead of r. And no doubt mass will also change. Let m dash is equal to mass of this central portion of the earth having radius r minus d. Then again by definition g is equal to at the surface gm upon r square, equation number 1. gd is equal to at depth d, value of g, gm dash upon r minus d whole square. If we divide gd by g, so it will be gm dash upon r minus d whole square, r square per gm, g cancels. So now we have to find value of m dash and n. To simplify the equation, so mass of earth is given as volume into density. So m is equal to 4 by 3 pi r cube into rho. So density is supposed to be uniform. Therefore m dash will be equal to 4 by 3 pi r minus d whole cube into rho. So if we divide m dash by m, so 4 by 3 pi cancels, rho cancels. So m dash by m comes out to be r minus d upon r whole cube. And we substitute in this equation gd upon g, r square upon r minus d is already here. So first you substitute value of m dash upon m. r minus d whole cube upon r cube. So r minus d square whole square cancels with cube. So r square cancels with cube. So it only remains r minus d upon r. So acceleration to gravity at depth d is given by dd upon g is equal to r minus d upon r, or dd is equal to 1 minus d upon r into g, where d is the depth, r is the radius of earth. So it is very clear, when d increases, g also decreases. So at the center of earth, d becomes r. When we go to center of earth, depth becomes radius of earth, so gd is equal to 0. So very, very important fact that acceleration due to gravity is 0 at the center of earth. That's why weight of the body is also 0 at the center of earth. So you may be asked that, show that weight of the body is 0 at the center of earth. So weight of body is 0 at the center of earth because there is no acceleration to gravity, and weight is given by mass into product of mass into acceleration due to gravity. Similarly, variation of g due to shape. So because g is inversely proportional to square of the radius. So since our earth is an elliptical shape, suppose r is the equatorial radius and rp is the polar radius. So as rp is less than re, therefore gp will be greater than ge. It means value of g is more at poles than at equator. Moreover, this gm upon r square is equal to g is also known as I, because nothing but gravitational force per unit mass, and this is known as gravitational intensity. So I and g are same. Gravitational field intensity and acceleration to gravity are same. So this is all about variation of g with depth, height and shape of earth, and what is meant by gravitational field intensity. So till next video, be happy, all the best, good luck.